if we need to take a number of different measurements and combine them in some way, so we needed to measure mass and volume to measure density, to calculate density, or we needed to measure the height and width of something to measure its area, or to calculate its area. We need some way of combining uncertainties from two measurements and coming up with an uncertainty for that final value. But before we go on to doing that, there's just a few terms that I need to describe or introduce. One is, if we have a measurement like this measurement that we took before, I've just noticed that this should be 0.3 volts. We define something called the absolute uncertainty. And that's just the raw uncertainty as it is with the same units. We also use something called the relative or fractional uncertainty. And that's just the uncertainty divided by the true value. And finally, we have something called the percentage uncertainty, which is, of course, just that uncertainty expressed as a percentage of the total. Notice I don't round these fractional and percentage uncertainties. I can kind of save my rounding of uncertainties after I've combined them at the end of my working. Okay, rule number 1. If I need to add or subtract values, I always add the absolute uncertainties. So, for example, just say I had the length of a field, 100 plus or minus 1 millimeter. A riveting example, I know. And the width of the field is 50.0 plus or minus 0.6 meters. And I want to calculate the perimeter of that field. So I know that my perimeter is twice the length plus twice the width. And if I put them all together, I get, say, 300 meters. I'm just going to leave it unrounded there for a moment. Because I'm adding those values together, I need to add up the absolute uncertainties. And because this is essentially L plus W plus W, I need to include 2 lots of the uncertainty in L and 2 lots of the uncertainty in the width of the field as well. And so if I add them all up, I get something like 3.2 meters. Of course, I need to round that up because that is an uncertainty, so it's 4 meters. And if I combine then, give my final answer is 300 plus or minus 4 meters, because I need to round my final answer to the same number of decimal places as my uncertainty. Just to reiterate, when you're subtracting numbers, you also need to add the absolute uncertainty. Just because you are subtracting the numbers, it doesn't take away the fact that you are uncertain about those numbers. So when you are subtracting numbers and making something smaller, perhaps, then in fact those uncertainties in those numbers become even more pronounced as in relative size to your final number. So it's really important that you add the absolute uncertainties. The next rule is, of course, for multiplying and dividing. Instead of adding the absolute uncertainties, you need to add the relative or the percentage uncertainties. Now I'll just write in here what the percentage uncertainties for these are. So the percentage uncertainty for L is pretty easy to calculate, it's 1%, and the percentage uncertainty for the width is 1.2%. So let's do another exciting calculation. Let's work out the area, which is of course the length times the width, which we get something like 5,000. I'm just going to leave that unrounded. It's meters squared. So to work out the uncertainty, I need to add the percentage uncertainties. So the percentage uncertainty of A will equal the percentage uncertainty of L plus the percentage uncertainty of W, the width, and that will give me 2.2%. And then of course, to work out I need to work out the absolute uncertainty for the area, which is 2.2% of 5,000, which ends up being 110. But of course, and what a pain, we have to round up, even though it's just over. I'll just put the units in there and squeeze this in at the bottom. The final answer is 5,000 plus or minus 200 square meters. So I've rounded that up to one significant figure and rounded my final value. I didn't need to round it, it was already 5,000. So 5,000 plus or minus 200 square meters. In the final example, or final situation, I'm not going to go into a great amount of detail, but we can look at it more when it comes up in our measurements. For all other operations, such as logarithms or trigonometric operators like sine and cos, we have a slightly different approach. There are proper ways of doing this, but one very simple way is to just calculate the maximum and minimum possible values for that function given what you started with. Sometimes you'll find that one will be larger, further away from the mean than the other, so you just use the larger as your uncertainty. It's not a perfect solution, but it'll give us a reasonable idea of the uncertainty. And that will equal your uncertainty. Right, that's it for combining uncertainties for now. Hopefully this will make a bit more sense when we put it into practice in the following weeks.